Hey, Algebra AB, this is Tony Koo Coach, obviously, working on our overtime extension here. So we're going to be backtracking. You could also use basic moves, of course, but we are going to come across problems when you want to take the square root and it's just not so simple to do so. So let's check out a few. The first two are going to be similar and the third one's a little different, and then you'll try a few practice problems on your own after that. So number one, solve x squared minus 7 equals 17. So I start with x, and I know the first thing that happens to x is it gets squared, and then I subtract 7, and I end at 17. So naturally, we go backwards here. We add 7, and we get 24. And now I do my positive square root and my negative square root from 24, but I realize that 24 is not a perfect square. So when I need to break down the square root of 24, I have to think about what are two numbers that multiply to 24, where one of them is a perfect square. And I have quite a few options here, but then I realize the only perfect square other than 1 here is 4. So I write 24 as the product of 4 times 6, or the square root of 4 times the square root of 6. The square root of 4 is just plain old 2. So we get 2 times the square root of 6. That would be my positive answer. And my negative answer is negative 2 times the square root of 6. So just recognizing that occasionally you're going to have to simplify that radical. Now, you won't see this on a quiz or a test necessarily, but it is the same concept, backtracking with that extra step when you don't have a perfect square. Let's try the second one. 3x squared plus 1 equals 37. So I start with x. We square it because of order of operations there, then multiply by 3, and then we add 1 and arrive at 37. Going backwards here, subtract 1 is 36. Divide by 3, we get 12. And now we have to take the positive square root and the negative square root of 12. Square root of 12, that's 3 and 4, 6 and 2, 1 and 12. I like that 4 and 3. So I write that as the square root of 4, square root of 3, or 2 times the square root of 3. So I get positive 2 root 3 and negative 2 root 3 for my x values. All right, and again, if you want to write those out, you can write like x equals plus or minus 2 root 3 is your final answer, or x equals 2 root 3 and negative 2 root 3. You can do the same here. X equals plus or minus 2 root 6, or x equals 2 root 6 and negative 2 root 6. All right, let's do the third one here. This one is actually a little bit quicker and easier than the first two. So we need to solve 2x squared plus 13 equals 5. So we start with x. It gets squared. Then it gets multiplied by 2. And then we add 13. And we arrive at 5. So traveling backwards now, subtract 13. That gives me negative 8. Divide by 2. That gives me negative 4. And now I need to do my positive square root and my negative square root to undo the squaring. But if you think about putting the square or negative 4 underneath the radical, remember, we can't take the square root of a negative number. Remember, there is no two numbers that multiply, or no number that if you square it or multiply it by itself that will give you a negative number. That's not possible, right? Positive times a positive is positive, and a negative number times a negative number is also positive. So there's no way to square a number and get a negative value. So therefore, when I go to square root a negative number, I can't. So this actually leads us to no solution. There is no number or numbers that I could substitute in there for x and get a real solution here. So that's our extension. I'm going to give you 3 or 4 practice problems that involve these concepts, as well as just going a little bit further with the idea of backtracking, maybe a couple extra steps. All right, good luck.